What's happening, dogs? It's Mr. Allen with an introduction to similar figures. I got a couple triangles up here, A, B, C, and we have triangle D, E, F. And they are, in fact, similar. But why? Well, there's two things that need to be true in order to have similar figures. The angles, the corresponding angles, need to be congruent, so let's jot that down. Corresponding, it's a long word, angles, congruent, and the corresponding sides need to be proportional. So corresponding, I'm not going to write that out again, sides proportional. Okay. Well, I think we know what corresponding angles being congruent means. That means that A and D are congruent, B and E are congruent, C and F are congruent, right? So these two triangles are similar. But what does it mean to have proportional sides? Well, if I were to give some lengths here, let's just go with some lengths. Let's say that AB was 4. All right? And then let's say that DE was 8. And I'm also going to jot down a quick similarity statement here for these two triangles. Triangle ABC is similar to triangle DEF. And how did I know that, besides the fact that I wrote the problem? Well, A and D both have one single arc there. They are congruent. B and E have the doubles there, so they're congruent. C and F have the triples, so they're congruent. My corresponding angles need to be in the proper position there. So this is a similarity statement which you may be asked to write in future problems. So back to this here. If I got AB is 4 and DE is 8, what if I gave a length to BC? Let's say this one was 5. Could you tell me anything about a length in triangle DEF? Well, according to this one here, if this is 4 and that's 8, and the sides are proportional, 8 is double the 4, right? So doubling the 5 to 10 should give me this guy right here. And then let's give another arbitrary length to C. I'll just go with 6 here. We'll go in order. Well, if AC is 6, that means that DF has to be double that, which is 12. And it all stems from the fact that I gave you the 4 and the 8 here, and that the sides are proportional. But isn't a proportion like two fractions equal to each other? It is. Check this out. We're going to write out a super proportion here, as I like to call it, based off of this similarity statement. And we're going to pop some numbers in, okay? So for triangle ABC, I would have 3 sides here. So super proportion, right? 3 of them. We're only going to use 2 at a time when we are doing some calculations, but we can write out our entire triangle or any other figure we're dealing with, all the sides. So AB will be the first one. BC I'll do for the second. And then AC will be the third. And I'm going to go in the same order for triangle DEF, but I'll write it in my denominator here. So DE is the first, EF is the second, and then DF is the third. Okay. Notice how the AB and the DE match up with each other, the first 2 in the triangle. The last 2, BC and EF, are right there. And the outside AC and DF, that's the last fraction. Now, could I put these numbers in, these values that we have? Absolutely. Let's do that. So I'm going to set up the proportion again, blank. And I can plug in the 4, the 5, and the 6 in the numerator. And the 8, 10, and 12 in the denominator. 8, 10, and 12. And what do all 3 of these fractions simplify down to? 1/2, right? They all simplify down to 1/2. In these 3 fractions, they are equivalent to each other. The sides are proportional to each other. So there we go, man. Only need those 2 things to prove that 2 triangles are similar, or 2 figures rather, because it could be rectangles, they could be any quadrilateral, they could be similar to each other, even going into other polygons like octagons or pentagons or whatever. If the sides are proportional and the angles are congruent, then you have similar figures, right? Or if you have similar figures, those things are true. There's ways to prove similar figures with less information, just like with congruent triangles. You can prove with just 3 sides or 2 sides and an angle. Same kind of deal goes here. With similar triangles, you can do it with just 2 angles, and there's a couple others as well, but we'll tackle that in another video. So these are just the basics right now, an introduction to similar figures, which are pretty awesome. All right, so check out some more videos, just an intro here, and have a great day, guys.